Hi guys, we're up to electrical video number 4 now. The big change on this one. This one has, if you can come in closer here and kind of get me a close-up of this, Mr. Cameraman. This one has 2 electrical switches and 1 light fixture. In the past, remember, we've only worked with 1 single pole switch. With this one, we have what's called 2 three-way switches. A three-way switch is kind of interesting. It has a black common terminal here on the bottom, and that terminal either allows power to come in or allows power to go out, depending on where it's located in the circuit. The 2 top terminals are called travelers, and they're always brass in color, and the common terminal generally is always black in color. Okay, and notice on this switch, it does not say on and off. There's no indication on it when it's on and off. Although with this switch, when both switches are going in the same direction, it's off. Now that could be off both facing down, or it could be off both facing up. Now the switch itself is on when they're opposing each other. So I have this one down, this one up, the switch would be on. Or I could have this one down, this one up, and the switch would be on. That's basically how it works. Now, what the traveler terminals do, and the reason there are 2 of them, is they allow a pathway from switch to switch for the electricity to flow through the switches and get to the light fixture. So since we have 2 positions where this thing could be on with this switch up, this switch down, or with this switch up, this switch down, since we have 2 pathways, we have to have 2 traveler wires. Okay? Now, the electrical current is coming in from the source, which was 14.2 Romex, which is what we've used in the past. It's coming in, it's attaching to the bottom of the black or common terminal on this switch on our left side, and then we have a red traveler wire on the right side. We have a black traveler wire on the left side. Now, this could work if the red was on the left and the black was on the right. That makes no difference, just as long as they correspond with each other on both switches. But you can't have the red on the right side and then have the red on the left side on the other switch. The colors do need to correspond, the wires do need to correspond. If this one's on the right, make sure it's on the right over here. Now, you'll notice the addition of 1 color of wire in this particular project. That's because in between our handy box and our octagonal boxes on both sides, we used a 14.3 Romex. Remember, 14 was the gauge of the wire. 3 in this case indicates that there are 3 color-coded wires. There's the red wire, the white wire, and the black wire, respectively, as to how they're connected determines whether they're neutral, hot, or whatever. Okay? Now, also notice that when we got up here, and I mentioned this to you once before in our last project, sometimes a white wire and a black wire can connect. When that happens, essentially what you're telling everyone is that that black wire turned this wire into a black wire. So this black wire turned this white wire into a black wire. And the way we indicate that is to black the end of the white wire. So we black the end with a Sharpie about 1 inch or so on every place that attaches, both on the switch and where it combined with that wire. So that tells everyone that's now a hot wire, it's not a neutral wire. Remember, the only place we have a neutral wire in this circuit is from the source, and we combined it here with another white wire, making that a neutral wire, and it found its way to the silver terminal on the light switch. So we still have the same principle as the preceding circuit, in that we have to find the silver terminal with that neutral wire. Now, the common terminal on this side is allowing electricity to flow into the circuit. The common terminal on this side is giving the power to the light fixture. Okay, so they have a little different function. They're both hot wires and they both have electricity flowing through them, but this is energizing the light fixture. This is being energized by the source and allowing the electricity to flow through. So we have the switch down on this side, up on this side. That tells us it's on. Down on this side, down on this side, it's off. Flip it up on this side, down on that side, it's on. Both up, it's off. So whenever the switches correspond to each other like this, both up or both down, the circuit is closed and the light is off. But when they alternate from each other, down, up, or up, down, then the circuit is energized and the light is on. I also did a drawing for you guys on this circuit. If we can get kind of a close-up of the drawing, you can see how I took the black source hot wire up to the terminal, the common terminal, and the neutral the same way. And you can see how everything flows through the drawing. And that's exactly what we've got here in the actual product. Okay, now I made a legend for you, A through H. Disregard C. I was gonna add something else to it as a challenge for your final, but I decided not to. Now your final, excuse me, is gonna be a lot like this. Okay, so it's very important that you master this drawing and the way the electricity flows through this product. How it goes through, what makes it on, what makes it off. You're gonna have to be able to answer those questions. I'll generate all that stuff by, probably Thursday afternoon, Friday maybe, and then I'll send it all out to you and we'll get started on the final. The final I'll expect to be back by, the end of class on Wednesday, and then I'll have them graded and have my grades turned in by Monday the 12th. Okay, so I don't really have anything else to add to this particular circuit. You guys make sure you study that drawing. I would suggest that you even do it yourself a few times so that you can know how the circuit works and where the wires are coming from, where they're going through, because in the test you're actually going to have to draw your own circuit. I'm only going to give you the S3, and a light fixture, and you guys are going to have to figure out what wire goes where the source, I'll tell you where the source is, but you're going to have to figure out everything else from there and do the legend on your own and answer some questions about the circuit. So until next time, guys, see ya. Bye.